Hi, in this video I want to look at a diode circuit called the rectifier. Okay, and we'll just take a look as to why this circuit is called a rectifier. But let's just start by building the circuit and looking at how this works. So the rectifier has an input which is usually an AC input. Okay, uh, you know what an AC input means, right? It's basically a sine wave input or something like that. And then you have a diode here, and the diode is connected in series with a resistor which is connected back to the power supply. And what we usually do is we take the output of this circuit across the resistor. Okay, so this is going to be V out, and let me just move this circuit a bit to the side, and therefore this is V in, let's say. And let's try to figure out how this circuit works. Okay, so one of the things that we can do in this circuit is to figure out how this circuit works is to realize that the V in is a sine wave, right? It's like an AC signal, and therefore this signal can, if I call this the zero volts, so the signal has a positive cycle to it and it's got a negative cycle to it. So this is the positive cycle and this is the negative cycle. And in the positive cycle, the power supply is trying to push a current through the diode in the forward direction, and therefore that current is going to flow through the diode. And in the reverse bias, because the voltage here is negative, the power supply is trying to push a current in the opposite direction, in the reverse direction, and that current is not going to flow. Okay, so another way of saying it is, uh, when the when we are in the positive cycle of the input, the diode is in forward bias. Now, if it is in forward bias, how would it look? So, if it is in forward bias, you can replace the diode here with just a short, isn't it? And then what happens? V in becomes equal to VO. So, let's just write that down. So, what we are saying is when, or let's say if, V in is greater than 0 volts, we have V output equal to V input. So that's the forward bias region. What happens if V in is less than 0? So if it is less than 0, then what we have is, instead of the diode being in forward bias, the diode is going to be in reverse bias, and the voltage, and there is going to be no current flowing through this, and the voltage here VO, so there's no current flowing through this resistance, so the voltage difference between the resistance, across the resistance, is going to be 0, right? I is 0, I times R is 0, so VO is going to be 0, and therefore we have VO equal to 0. Okay, so if this is the case, now let's try to plot the output of the circuit, and let's try to do it over this graph. So in this region, V in is greater than 0, right? If it is greater than 0, we said VO is equal to V in. So your output, you get exactly the same as V in. Okay. In the negative region, so when V in is negative, what happens to output? Output is just 0. So we have voltage like this. And then again, when V in becomes positive, we have, it follows the uh, input, and therefore the output that you get looks something like this. So let's draw the input and the output again. So if this is my input, okay, my output is going to look like this. So let me just draw it with a different color, and what we have is, so let's just mark the points. Okay, and what we get is, in the positive cycles of V in, you get V out exactly to be the same, and then 0 here, then equal to Vn, 0 equal to Vn, and so on and so forth. So what a rectifier does is it does not allow negative voltages to pass through, and it only allows the positive voltages to pass through. So in one sense, it is rectifying the signal. So think of it this way: the signal is going in two directions, right? It's going positive and negative both. That's what the input is doing, and the output is rectified. There is no negative voltages there. It has been rectified. So this operation, where you only allow the positive voltages to go through, is called rectification. And to be more precise, this kind of rectification is called half wave rectification. So half wave rectification. What does that mean? We call it half wave because, can you see, only half of the wave, half of this input signal is being passed through. The other half has been just simply cut off. A full wave rectifier will be where this negative voltage is going to be flipped, and you get a wave, uh, the negative side is flipped to the positive side, and that would be a full wave rectifier circuit.